All right, so today we're in section 9.4, rational numbers. Okay, so a couple things real quick. A rational number. Okay, well, what do you think of when you think of the word rational? Okay. Huh? Okay. In terms of like real world stuff, all right? If I said, well, that was irrational, okay, the opposite. What do I mean by irrational? It doesn't make sense, right? So irrational doesn't really make sense. Well, irrational numbers kind of fall in line, and that's what we're going to learn in 9.5. So rational numbers, if something's rational, it makes sense, all right? And in terms of numbers, it means it's a whole number. It could be a repeating decimal or a terminating decimal, all right? So this whole difference between rational and irrational numbers. All right, and one thing I probably should have added in here, no matter if it's rational or irrational, all numbers are what we call real numbers. We'll talk more about that in section 9.5. But both of these numbers are called real numbers. What's the opposite of something being real? Not real. Okay, yeah. Or, I heard it, fake. There's no such thing as a fake number, okay? So every number in the universe is a real number. And underneath real numbers, we have rational numbers and irrational numbers. And that's the definitions that you see above. Oops, I can't spell. Irrational. Who laughed? Okay, rational and irrational. All right, so today we're focusing on rational numbers. How can I show that a number is rational? All right, and there's a couple different ways that I can do that. All right, so in example 1, all right, here's really kind of like the key behind showing that a number is rational. It's showing that it can be written in what we call A over B form. All right, so we say A over B form. Well, what does this mean, A over B form? It means that I can write it as a fraction, right, as a fraction. So what I'm going to do here in each of these examples is I'm going to show some converting between fractions and decimals. And what I'm essentially doing here is I'm showing that these numbers are whether or not they are rational. Okay, so in this example, we are going to write these fractions as decimals, okay? We're going to write these fractions as decimals. That's what the directions would say in this section on your homework, is to write the fraction or mixed number as a decimal. All right, so 1 4/5. That should say 4/25. I'm sorry. 1 4 over 25. 1 4 over 25. So if there's a whole number out here, or essentially it's a mixed number, I know that that means that there's a number in front of the decimal. That stands for a whole number. All right, so now I need to change 4 over 25 into a decimal. We're going to use simple operation in our calculators to do that. Okay, we're just going to divide 4 divided by 25. 4 divided by 25. Okay, and make that simple conversion. All right, and what would it be? What's 4 25ths converted to a decimal? What is it? 4 over 25. Okay, so that's going to be the decimal version. Now, is that it? Are there any numbers after that? It's just 0.16. So this is what we call a terminating decimal. Okay, this decimal is terminating because it stops, it ends. All right, so all we're doing is just converting these fractions to decimals. All right, so 5 over 33. All right, go ahead and convert that also to a decimal. Okay, so 5 divided by 33, and what do we get? Yes, 15 repeating. All right, so because this is a repeating decimal, again, it is a rational number. All right, -2/9. All right, just because it's negative does not mean it's not going to be rational. So that's another concept we need to understand about rational numbers. They can be positive or negative. What I'm really concerned with is, does the decimal terminate or repeat. Okay, and as long as it does one of those, then it's rational. So negative 2/9, when I convert it to a decimal, what would I get? Negative 2. Okay, 0.2 repeating. All right, so just doing these simple conversions. All right. Yep. Negative 0.2 repeating. All right, converting fractions to decimals. Any questions? All right. All right, so now we have repeating decimals. 1.25 repeating, 0.8, and then it keeps repeating, 2.06 repeating. So we have these repeating decimals, all right? So we know if it's a repeating decimal that it is a rational number. And now I need to take the repeating decimal and write it as a fraction. Go ahead and write down these 4 values. Okay, and we'll go over it. So, to change a repeating decimal to a mixed number. All right, so let me kind of explain some of what's going on here. All right, so we know that the last digit in this, the last place value in this number is what place? It's the 5 is in the hundredths place, right? 5 is in the hundredths place. Okay, so in order to convert that, we're basically dealing with that place value. All right, so in your calculators, I do want to teach you this function in your calculator as well. We have 1.25 repeating. You're going to put in 1 point, and you see your alpha button? I want you to hit that alpha button. And then you see the square root button. In pink, there's a shaded in box with the line over it. You can hit the 2.5. All right, and hit equals. That gives you the improper fraction. All right, to make it a proper fraction, you would hit shift and then S to D. All right, and that's how we would convert a decimal to a mixed number. All right, tomorrow I'm going to show you the process behind that and basically how we can even set that up in an equation. Okay, so to convert 0.8 repeating, all right, you would do the same thing. You would just put it in your calculator, point, but then you would need to go alpha, square root, and then put in your eighths. All right, help your buddy if they need help. Equals, and that'll give you a fraction. Okay. And then shift S to D would change it to a mixed number if you needed to, but in this case, it just stays 8/9. All right, so I'm going to walk around and kind of check on you guys and see how you're doing with those conversions. All right, so just converting repeated decimals into fractions and mixed numbers. All we're showing here is that there is basically a transfer between the two. These are rational numbers because I'm showing that repeating decimals can also change into fractions and mixed numbers, and basically that's what shows that they're rational. All right, guys, so 2.0, all right, alpha, square root 6, put in the 6, hit equals, and you get 31/15. Okay, so here, right here, I show this can be written as a fraction, 31/15. All right, and then I can go ahead and convert that to a mixed number, which is 2 and 1/15. All right, 2 and 1/15. So just converting repeated decimals into fractions and mixed numbers. What did you get for negative 4.5 repeating? Negative. No, what did you get, Mendora?
Negative 50 over.
Yes, 50/99. 50/99. Okay, negative 4 and 50/99. Again, just showing that conversion between the two. All right, so here's some challenge questions. Because this section becomes greatly simplified with the use of a calculator, which we are permitted to do on this section, it's going to be really important that you understand basically rational and irrational numbers to the point where you can even give your own examples. You know how yesterday on your test you actually wrote your own example of an equation, which you guys actually did really well on? That's what you're going to be doing here in this section as well. So on this quiz that you're going to have next Wednesday, you need to be prepared to write your own examples of rational and irrational numbers. All right, so let's focus today just on the rational part. We're actually going to come back to these challenge questions after we learn section 9.5, which is the irrational numbers. So how can you identify if a number is rational? What have we been saying in these examples? It has to have one of two characteristics. Michael?
It can be written as a fraction.
Okay, it can be written as a fraction. It has a terminating decimal. What does it mean for something to terminate? It means that it ends, it stops. All right, so it needs to have a terminating, or what other type of decimal have we been dealing with? Or a repeating decimal. Okay, so those are the characteristics that I'm looking for in these rational numbers. Okay, so sections 9.4 and 9.5 really go hand in hand between the two. All right, so that's the criteria I'm looking for a rational number. And now I need to give an example. An example of a rational number. I'm going to give you a few, and then I want you to come up with a couple. An example of a rational number is a whole number, 12. It's an integer, -8. It's a fraction. Can anybody give me a fraction? Any fraction? What is it? 1/8. Can be written as a fraction. What about, can anybody give me an example of a repeating decimal?
0.6 repeating.
Okay. 0.3 repeating, 0.16 repeating. Just show that bar notation. 0.3 repeating. What about a terminating decimal? Can anybody give me an example of a terminating decimal value, Seth? Terminating decimal, any? Doesn't matter. It could be a negative, could be a positive. All right, can anybody get just anything? Mike?
0.153.
All right, 0.153. Just something that shows that that decimal value stops, it ends. 0.85, 0.92, -2.68. All right, so on your paper, I want you to give me 3 examples, and they have to be different. So it could be a whole number, could be a fraction, could be a terminating decimal, could be a repeating decimal, but I want you to give me 3 examples of a rational number. Okay. Calculator, what's one that you wrote? Just any example. You didn't write any? You can't write a whole number? Trayon?
See all 4?
Just give me one. Give me one of them.
0.21 repeating.
Okay, so repeating decimal, rational. All right, Medora? 17. Whole number, rational. Timothy? 0.587. Terminating decimal. It stops, it ends. Rational. Michael?
5/12.
5/12. Written as a fraction. It's rational. Kayla? 1/4. Written as a fraction. Also can be written as a decimal. Rational. Ruben? 8. Nora? -4. Integer. Negative number. Rational. You see, guys? All right, so rational numbers really make up the majority of numbers. Actually, there's only really one type of number that's irrational, and those are the decimals that just keep going on and on and on forever, and they have no pattern, and that's what we're going to learn in 9.5. So we'll come back to these challenge questions after we learn 9.5, and it's really important that you can, I'm going to use a big word here, but conceptualize. Basically, you can take in this concept and put it out on paper, you can make up your own problems. You can make up your own. These are rational numbers and these are irrational numbers. That really shows us that you understand. Because is it possible for me to teach you every number in the universe that's rational or irrational? No, that's impossible. But if you understand the rules that make a number rational or irrational, then you can pick any of them out. All right? It's very possible that on a quiz or a test, you're going to see numbers, and it's not just this concept, it's a lot of concepts in math. You'll see numbers you haven't seen before, but if you understand the concept behind it, then we're okay. All right, modeling real life. Okay, the weight of an object on the moon is about 0.6 repeating times its weight on Earth. An astronaut weighs 192 pounds on Earth. How much does the astronaut weigh on the moon? All right, so we're going to use this concept of rational numbers, knowing that it's a repeating decimal, and we're going to solve this problem. Okay, so we are going to take 0.16 repeating. All right, I'm going to walk you through this, okay? And x equals the repeating decimal, all right, which is 0.16. Repeating. All right, so the first question you need to ask yourself is how many repeating digits, okay? So the bar notation above it is really important. How many repeating digits do I have? You have 1, okay? So if you have 1, then what you're going to do is you're going to multiply both sides by 10, okay? Now, if you had 2 repeating digits, then you would multiply both sides by 100, okay? These are powers of 10. So if you had 3 repeating digits, what would you multiply both sides by? 1,000, okay? So we're just increasing them by powers of 10. You're only going to see, guys, either 1 or 2, all right? So if it's 1 repeating digit, you're going to multiply both sides by 10. And what that's doing is that's moving or shifting the decimal to a point in the decimal value where it isolates the repeating part of it by itself on one side of the decimal. You'll see what I'm talking about in just a second. All right, what's 10 times x? That part is pretty simple. What is it? 10x, okay? And when I multiply a number by a power of 10, what's happening is I'm moving my decimal to the right however many places. If it's 10, it moves to the right 1 place. If I multiply by 100, it moves it to the right 2 places. But what I'm trying to do is now get this repeating decimal by itself, all right, on one side of the number, which I did, okay? You with me? Yep, I need the 10x. All right, so now I'm going to subtract the original equation from this. All right, so basically step 1 was x equals 0.16 repeating. I multiply both sides by 10 to isolate the repeating decimal on one side of the number. And now I'm going to subtract my original. All right, I'm going to put this in parentheses. My original decimal value. Okay? Well, what's 10x minus x? What's 10x minus x? No, well, 10, what's understood in front of the x, guys?
1.
A 1, so what's 10 minus 1?
9.
9x. All right, now calculators allowed. What's 1 point, you got to hit the alpha button again, and the square root, 6, repeating, minus 0.1, and then hit the alpha button again. All right, hold on, sorry. Oh gosh, it's not going to subtract. Huh? Yeah, it's not going to do it. Okay, so I'm just going to tell you what happens here. When you subtract these, what's happening now is that repeating decimal cancels out. Okay, and it can lower, instead of it being 1.6 repeating, it just lowers it by 1/10, now to 1.5. So if that had been 1.9 repeating, when I subtract the original equation, it's now going to be 1.8. All right, it takes that repeating part off of the decimal, so I can actually come up with an even number. All right, repeating decimals go on forever, so to come up with an actual answer is pretty much impossible. So I'm trying to eliminate the repeating decimal so I can come up with an answer. All right, so now that I'm here, it's a simple step to get to my answer. Divide both sides by 9. Divide both sides by 9. All right, and we're going to go over this more tomorrow on day 2 of 9.4. X equals 1.5 divided by 9 is 1/6. All right, so to answer the question, he weighs about 1/6 his weight on Earth when he's on the moon. So what was his weight? 192. So I can take 1/6 and I can multiply it by 192. All right, once we do a couple of these, practice, and again, we're going to do this together tomorrow. It's not on your homework tonight. Your homework tonight is those converting problems, okay, which hopefully won't be too much of an issue. 192 times 1/6, 32. So if he weighs 192 pounds on Earth, he weighs 32 pounds on the moon. All right, so that's it for part 1 of 9.4.